Hey there, my gorgeous friends on the internet. Today, it's an episode about promises. Callback hell, event loops, text stack, call stack. Oh my god, await, async. There's so much to do. I'm getting a headache. But we're gonna cover all of that in this episode. It's a core essential concept in JavaScript to understand. And once you understand all of these different bits and bobs that are moving around, you're gonna understand how most of these asynchronous libraries work as well, and what's really going on under the hood. Some people also ask me what wallpaper I'm having. This is from Steam Wallpaper Engine, and you get these cool live wallpapers. There's a fan moving there, can you see? It's animating. It's really cool. All right, let's get into it. I also want to say that the next update on developbyed.com is going to be the JavaScript course and the React course. So if you're interested in learning more about these, check out developbyed.com, and also would be a great support for me. So thank you so much for buying everything. All right, so we are in JavaScript land right now. So let's put up a simple example, a console log 1, 2, and 3. So if you worked with JavaScript before, you might have heard that JavaScript is single-threaded. And what does that mean? It means that when we're parsing this code, the JavaScript interpreter is going to take a look at these one by one, and it's going to start executing them in order, 1, 2, and 3. Now, before we get into the promises bit, I do want to illustrate a couple more things of how this code is actually being run. So the code that we're running up here is called the global execution context. All right, and there is one more context to be aware of, is the function execution context. So if I make a function here called like logger, and I'll just say console log 2 and 3 down here. All right, so if I run logger up here and run this, we are going to get 2, 3, and 1. Why is that? Well, there's a concept called call stack, and I'll show you this. Thank you so much, Theo GG, by the way, for this Excel draw thingy that I saw that you're using. It's fantastic. God damn. Timbaland. Justin. Sorry, I love that song. Anyway, so what happens is the environment that we're running our code is essentially our global execution context. So that gets added to this thing called the call stack right here. And the call stack is a way to keep track of what code we're running at what time. All right, it's just a way for JavaScript to know what the hell is going on. So if I have something like a console log message here, of course that's gonna run first, right? So if I run this, we get message, but then we get 2 and 3. We're not getting console log 1 here. So why is that? Well, our main here, again, is our main execution context. That gets added to this call stack. And the way the call stack works is the things get stacked on top of it, right? And the things that are on top of it get executed. And once they finish executed, they get removed. So in this case, we run console log message here, but then we run into our logger here, right? Which has its own execution context. So what we do when we invoke a function, we start running the code inside that function. So we run 2 and 3. So that essentially gets added here to the top of the call stack. So our main thread here, our main execution context is going to be stopped. All right, so nothing here below the logger. So I'll put stop. Come on. There we go. All right, so once the logger starts running here, everything below it will be stopped until our logger is finished returning. Now, whether that's a value that it's returning or it returns nothing, just void, it needs to run fully before we can continue down in this main context. All right, so once logger finishes, it gets popped off the call stack here. And then we can continue to run our main. So our main is going to keep running console log 1, and once that's done, boom, our call stack is empty. All right, so that's the idea behind it. Now you can do more complex examples if you want. You might have logger there, but you might also run another function in here called finish like that. And then I can run console log finished like that. And then I can run this maybe here. All right, so how is this gonna run now? Stay with me, we're gonna get to processes, I swear. So again, we're gonna run our main, right? So it's gonna run message. Then we get to our logger, so we're gonna go into our logger. That's gonna start executing here. All right, we run console log 2, but then we stop and we don't run console log 3 anymore because we're invoking another function here. So finish gets added to the top. And then finish is gonna run console log. That's gonna be finished, so it's gonna get popped off. Then we can continue with logger. So we're gonna run 3, that's gonna be popped off, and then we can continue with the rest of our global execution context. All right, so that's the idea behind the call stack. It's a way for JavaScript to know how to run your code. Okay, so here's another example where we have just 3 functions that run console log 1, 2, and 3, and then 1, 2, and 3. So if I run this, yeah, just what you expect. However, I'm gonna take the second function and I'm gonna replace it with a set timeout. Now be aware that the set timeout here is set to 0. So technically it should still run instantly, right? No, it doesn't. We get 1, 3, and 2. Why? Why, Ed? Why? Didn't you say everything is running synchronously in JavaScript? It's single-threaded. That's what you kept saying. That's still correct. Even though this does look like it's running asynchronously, technically it's not. What we're doing is we're offloading the set timeout. All right. So besides the call stack, what else we have here? Let me pull up the graph. We have web APIs like click, set timeout, set interval, scroll. All right, imagine you have like an on-click listener. If that would be added to the call stack, or maybe a large set timeout here, we wouldn't want to block the rest of our code from running, right? Then our websites become unresponsive. Like, well, if I have like a button that signs the user up, does that mean the rest of my code's website couldn't run? So what we're doing essentially is we're taking these things, these web APIs, and offloading it to the browser to run in the background. So let's say we have a set timeout of 5,000 seconds here. Can I not modify this? Okay, 5,000 seconds. What we're doing is the call stack is gonna pass it down here into the browser's web APIs. And the browser is gonna start running that in the background for you. Tick tock, tick tock, tick tock, time's up, motherfucker. And when the time's up, there's this event loop here. And the event loop's job is to start queuing stuff up to be added back to the call stack. So once this is done, 5 seconds is run, it gets added to this callback queue. All right, you might have active things running here as well, like a click listener, that maybe when you click, it's gonna like remove a to-do, like that. All right, so what happens here is, let's see, this is running here, right? 5 seconds, and then it gets added to the event loop here. And then once our whole call stack is finished, so there's nothing else running, the event loop's job is to start pushing things from the callback queue back to the call stack. And then once that's finished running, poof, it's gonna remove it. All right, and same like if you click on this button, it's gonna start putting, let's say you click 3 times, well, it's gonna add 3 different things, 3 different separate functions here to be ran as soon as the call stack is finished running. That's why you might have like a slow website running, you might have some weird funky code, maybe like you messed up a loop that's running for too long, and you click on a button and it's like nothing's happening, and then all of a sudden you get poof poof poof. It's because your callback queue has like 10 different remove to-dos queued up, and then once the call stack actually finished that large loop, it's just gonna push everything all of a sudden on top here, like that. Oops, sorry, it should be like one on top of each other. That's how the call stack works. First in, first out, I think it's called. And then boom, 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 they would start disappearing like that, okay? So that's kind of the mechanic behind it. It's this call stack together with the browser's APIs that gives you the ability to run stuff in the background, but it still runs synchronously because essentially just like queues everything up here to run synchronously anyway at the end. It just stops it from blocking the main thread. So how can we take this idea? Because it's unclear now that, oh, damn, you know, the second one has actually come last, right? There's no clear way of seeing that. So that's where the concept of callbacks came in. So I'll just remove this example for now. All right, so what's a callback? Well, essentially it's a function that's a parameter. So you can have a function, let's say like a logger here, that let's just say that takes in a message, right? Console log message. All right, so this is just a normal parameter. So I can pass in maybe a string. Hello. All right, normal function. Why did that not work? Hello, there we go, it worked now. Okay, cool. All right, so normal function. However, if I take this message and now make it a string, rather than making it string, I pass in a function. So I'll call it message, and I'll just make a message function here. It's gonna say console log, hello there again. Essentially, this became a higher order function now. And a higher order function is just a function that takes in another function in as a parameter. All right, and this is our callback here, this message now. All right, so if we run this, we get hello there. But how does this apply up here? Well, rather than doing our code like this, what we can do is in the second, we can pass in a callback right here. Callback, and I can run the callback right here. All right, so rather than invoking the third function, we can pass it in as a callback like that. So now this third is going to be added in as a parameter, and it's going to run after console log 2 here. So if we run this, we get 1, 2, and 3, kind of the behavior that we want to see. The problem with this approach is that it can get really messy and hard to read. I don't know about you, but I'm already having a hard time. I'm getting 3 different types of migraines going on up here looking at this code. But let me show you another example. What if we get some data back and then we want to do something with it, and then we want to fetch some more data, and then some more data and some more data, right? Or we want to fetch some data, modify it, and save it and push it somewhere else. And then based on that result, we want to display maybe a message on the screen. So you can make a callback hell. All right, this is kind of the problem that most people ran into. So you have a set timeout here, right? So that's our higher order function in a nutshell. Let's say this takes like 500 milliseconds to resolve. All right, and then I get console log. Let's say we got some data. Super cool. So now let's say with this data, or const data equals, let's say we have an object with a user of Johnny Boy, and hit save. Cool. All right, so after this, I need to, let's say I want to run another set timeout here. Let's say I want to take this data and modify it and push it back maybe to the database or something. So maybe this takes another 1,000 seconds. So here I can say data has been updated. All right. So if we run this, we wait a little bit. Oh, I never ran this function, sorry. Callback hell. Let's execute this. Run. Data has been updated. Cool. Actually, I did not even console log out the data here. Poof. User Johnny. Data has been updated. Cool. So essentially the idea here is that it's an effective way to ensure delayed execution of functions until the other one completes and returns with some data. But the way they look usually is quite nasty. So we want to avoid it. So I wouldn't even bother with it. So what are promises? Promises are just the completion of an asynchronous function, okay? We're expecting a result back in the future, or maybe an error back in the future. And based on that error or success, we want to do something with it, like display it on the screen or further fetch more data. All right. So it essentially accomplishes the same basic goal as the callback functions, but with many more features and a more readable syntax. So let me show you an example of how you can create a promise. So you just say const promise, and you can set that equal to a new promise like that. And this is going to take in a resolve and a reject parameter like that. All right. And in here, what we do is we either resolve it or reject it. So I can say resolve, we did it, baby, like that. Cool. And now I can take this promise like that and attach a dot catch finally or then on it. So when I add the dot then, here essentially I get back the resolved data from it. So if I console log data and hit save and we run this, we get we did it, baby. All right, so it got resolved. Now we can also reject it. Oh shit, server is down, boys. Hit save, we run this and we get an error. All right, so you're not gonna get anything here unless you also add a dot catch. So a dot catch is basically gonna catch any problems in your promise. So if there was a downtime, you maybe don't have the credentials to view the website, might throw you back a wee error, right? You're not authorized to view this content on this page, or you might not be a member. So in this catch, you can get any exceptions from this reject. So if I console log out, I call this error because you're gonna commonly see that. Look at that. Oh shit, server is down. All right. So if the promise does not get resolved in any way, it's gonna skip all of this dot then, because this dot then kept being chained on, and just is gonna skip directly to the sketch. All right, poof, error. And what I mean is that we can keep adding dot thens. Is let's resolve this in this case. I'm gonna say we got let's just make an object. Okay, we have a user called Blanca. I'm playing Street Fighter, it's fantastic. Okay, so if we run this, okay, we get Blanca there. Cool. But what I can do here is const data, let me call this user and set that equal to maybe data, or I can just return data like that. And if I return data here, what that means is I can add another dot then on it, and I'll have the actual user here like that. Oops, I messed up this dot then. It should have two parentheses like that. User. All right, console log user. So anything that you return here in the dot then is gonna automatically go down to the other dot then here, so we can use it. So run this and we get user Blanca as well. All right. Or if you're not returning, maybe you're returning another, maybe we're just saving the user here. Data is, sorry, we can do user is equal to data dot, I just called it just data, right? You might want to return and maybe run another fetch here. So we can go over to www.google.com. So this return here now is going to be the actual data from whatever we're fetching from Google. Or let me go to placeholder API and actually fetch some real world data. Where is it? Let's go here. Where's the good old placeholder API to use? There we go. All right, so if I pass this in here in my return, then this data here is gonna mean the actual to-dos from the placeholder API. So to-dos like that. So if I do a console log to-dos and run this, look at that, we're gonna get our actual response. All right, so you can chain together multiple .thens, giving you a more simple syntax on how your code actually works. So let's go back to that first example with the set timeout and see how it would look. So I can say const promise, set a new promise like that. Again, this is gonna take in a resolve and a reject. Cool, and here I'm gonna do a set timeout, and let's say this is gonna take maybe, hello, this is my data. This is my data from a server. It's gonna take, let's say, 2000 seconds to resolve, okay? Milliseconds, ugh. Okay, so let's see how it works now. So I can just say promise and add a .then to it. And then I get my response right here. I can just run an arrow function and say console log response and hit save. And now if I run this, 1, 2, and boom. Oop, res, not response. There we go. Run this again. 1, 2, and there we go. All right, so it makes it a bit more simple and readable on how, like, what is actually going on here. Now again, in most cases, you're not gonna create promises just for yourself out the blue. You're probably gonna use something like the fetch API, which is gonna return you a promise by itself. So if, again, I get the placeholder API, I'll just get this and pop it in here. So if I do fetch here like that, that's automatically gonna return me a promise, as you can see. So I can do .then again, which is gonna give me the actual data if everything goes through fine. So console log data, and we can run this, and there we go, there it is. We're gonna probably have to do data, we can just return data.json. And again, if I do a return here, that's gonna be chained to the other .then. All right, so here I'm actually gonna have the JSON version of that data. So JSON data. So console log JSON data. And run that, and there it is. But what we can also do is attach a .catch on it. So maybe the URL is not correct. So we can catch any errors here and say, oh no, something went wrong. If I run this, we get, oh no, something went wrong. And then you can also see there's a finally here. And this is gonna run whether the promise is rejected or resolved. It doesn't matter. At the end, it's gonna run finally anyway. So here I can say something like, well, everything is done. We tried. All right, and hit save and run that again, and there we go. So this is really nice, but with the introduction of ES6, we have async and await, which essentially is just syntactical sugar over the promises to make it look synchronous and very easy and readable. And the way you make it is you create a function and you add the async keyword in front of it. All right, so let's say we're getting the to-dos. All right, so rather than doing like how we used to do a fetch, right? You'd fetch the actual URL and then you'd attach all of these .thens on it. You just make let's just make a variable called response. And we can use this await keyword to await the result of this fetch call, all right? And that gets saved in here. And that's it. So if I do a console log response and a console log, let's say 2, all right, just a random number, and then I can do a console log 1 maybe on top of this. So log 1. Let's hit save and run this. Oh, I need to actually invoke this function. There we go, and run this. And if we have a look, we have 1, we have the response, and then we have 2. So it gives you the ability to have a synchronous code, like synchronous looking syntax, I should say. That's very easily readable and you know what the hell is going on. So here, what I want, if I want to make this a JSON, again, I don't need the .then to make it JSON, though you can. I can still go here, even though I'm using await, I can still chain a .then on it like that and say, well, just take this response and return me a response.json. Or what did I call this? Res.json. res.json. All right. So if I run this again, whoops. And I'll just go out here actually and say console log response like that. All right, so I still have the ability to do this, but there's no point to it when I can just get rid of it and go down here and just add another await. So I can say the actual data is await response.json. Look just how much cleaner that code looks like. So then I can do console log data, console log whatever the rest of my code is down here. If I run this, 2, we get the data and we get 2. Now be aware that in many new environments, like new versions of Node and some browsers, have the ability to not even need to create async and just have top level await. So essentially you could get rid of async there and add it to a function and just do await in the top execution context like that. All right, which makes it even nicer, thankfully. So now you just know if you see an await, okay, that's some code that's gonna run asynchronously. And in terms of error handling, what you can do is wrap up your asynchronous code in a try-catch block. So you could go and do a try, and let's pop that in like that. And then here I can say catch any errors like that, and I can say console log error and hit save. All right, so now let me also do a message here. Something went wrong, ... Cool, so let's say this is not returning something correctly and run this again. And we get fetch failed, something went wrong. All right, so just simplifies it, makes it look very nice and clean. And that's essentially it. Now there are a couple of other methods out there. If you want, I really recommend heading to MDN web docs here and just looking through all of these. There's another one called promise all, and this is really useful when you have multiple promises that you want to wait for all of them to finish before you actually display something to the user. So maybe, you know, someone bought a product, so a webhook is going to be sent, and it's gonna run some sort of promise to update that you have purchased the product, but maybe another asynchronous function is ran to send you an email or something. So maybe you want to wait for all of them to finish before you actually get back a message saying, hey, perfect, here's your product and here's a link where you can click and you should have an email sent to you by now. So it's a way to jumble up different promises that need to be ran, and then you're gonna get all of them back in this array, which is fantastic. So that's essentially it. Hope you enjoyed this episode. Let me know what you think, what I miss, what I don't miss. And yeah, I kind of want to keep up with this series, maybe of having a specific thing about JavaScript being covered on the channel, and we'll just go do a wee deep dive in it. I think that's quite fun. So anyway, thank you so much. Drop a subscribe, it's free, goddammit. Click it now. Is it clicked? Click the like as well. Look over to your shoulders, make sure everyone else is doing it as well. Thank you so much. All right, I'll see you in the next one.